So welcome. I want to thank you, all of you who are joining today in this meeting, virtual meeting. This is a small project that is on the side of teaching. In the past, we have discussed maybe the possibility to have a space or a platform where we can actually share a couple of ideas regarding technology, computing, computer science, of course, applications of technology. In the past, we have the Hackers Corners. Probably some of you remember, where we meet regularly every Friday, and then we discuss a couple ideas, or students can actually get together and work in assignments. This was an initiative from Valentin Becerra. It was a couple of years now, and it's been a very successful initiative that we have in the past. Because of the circumstances that has been appearing, now we're a little bit forced to work actually virtually, and that's something that it reminded me to come up with this in order to keep the spirit of computing and learning and whatnot. Excuse me. So what we're doing right now, it's a series. It's gonna come a couple of series of a couple of events that we're gonna have, a couple of interviews, a couple of segments in computing that we're gonna use in some blogs maybe, and I can actually work around special topics upon request. Yeah, we are a very rich community where we learn a lot of different from each other. So we're gonna keep using this platform to interview, to bring experts in the field, to bring thinkers to help us to understand certain problems that is happening, or not necessarily problems, but maybe some ideas that is happening and how can we apply them. So that's why we're creating this lab, if you want to say it, right? So today we are very fortunate to have Dr. Andrzej Pownuk. Probably you have seen him in many different areas. You probably see him in the hallways. I saw him on teaching computer science, teaching math. And I'm going to talk about a little bit of his current experience, because he is currently professor in the Department of Mathematical Science at the University of Texas in El Paso. But in addition, he teaches computer science in El Paso Community College. That's how we're actually creating a very strong faculty, because the background that Dr. Pownuk has, he has a collection of degrees, not only from the United States, but also he has postdoctoral positions that he has developed, or he has actually created in Poland. And he has a couple of work that he did in Austria, Vienna. And of course, he was a research engineer in Chevron corporations in California. So he has a lot of experience, not only in computer science, not only math, but also in engineering. This is very, very rich, which gives a very nice application when someone designs or a problem, a solution for a problem. You need to have this whole context. And I will share his website in the chat, so all of you can see all the work, maybe right now, maybe after. Let me see if we can receive that after the meeting. So all the work that he has been developed for the past years is being significant in computational science. This will bring us to the topic, which is computational science and the impact of computational sciences nowadays. And with no further ado, I'm gonna let Dr. Pownuk speak. And actually, you wanna say a couple of words, Dr. Pownuk, about...
Okay, so can you hear me first of all?
Yes.
Yes. Ah, okay, good. So if maybe I can share screen or something so I can have some kind of more specific topics. Would you like to, I don't know, do that kind of approach or?
Sure, you can share a couple of things and then we can go back and forward. So discussing this.
Okay,
Can
so
you share
let's,
screen, Dr. Pownuk?
okay, yeah, well, I can try at least. Let's see, you cannot start screen share while other participant is sharing. So I don't know, or you know what, if you
I
want
will.
me to go over this presentation, which is like right now, well, no, I'm okay with that.
Let me
Okay,
see.
so you know what, maybe, no, okay, so you know what, I can just talk about these things. Okay, so that's
Well,
good.
I'll make you host right now. Don't forget to make me host again, just to have
No, no, no,
control of
no,
that.
no, 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 no. So no, no trouble, no trouble, no trouble. Okay, so no, I can do these things as we are now. Okay, good. So let's start like this. Oh, so if I understand correctly, I'm supposed to like give some overview about computational science. Yeah, so
Yeah.
that's interdisciplinary fields, which is a kind of on the crossroad between computer science, mathematics, and engineering. And well, the goal is to get something out of that. Yeah. So well, I would say the most successful results of that kind of uh, collaboration would be to look at some maybe specific uh, applications which are uh, let's say popular right now. So it is sometimes hard to say what is the specific discipline where they belong. That's why we can say they are related to computational science. So let's say, okay, so one thing is engineering design. So we have some kind of software which is necessary for engineers to design, and this is where is okay. My origin is from that kind of thing. So we have some engineering problem when it's necessary to create some application which actually implements this problem and help engineers to design a particular solution. Yeah, so these are the let's say classical application of this computational science business, and here we have the need for parallel computing, supercomputing, and all kinds of things like that. So more specifically, we have this computational fluid dynamics, computational solid mechanics, air like planes, all kinds of things like that. Civil engineering, mechanical engineering in general, things like that. Yeah, so that's why, well, we talk here about computational science because, well, if people would like to create big application in these fields, then, well, at some point, this computer must be bigger and bigger and bigger. Computational complexity is bigger and bigger and bigger. Then, well, that would be one place where this computational science is necessary. Okay, recently, I would say a kind of show up some other things which were not that popular some time ago, and I would say this is this whole business related to data science, machine learning, and all these fields require lots of you know, computations and parallel computing and things related to that. And yeah, so that is also something related to this computational science business, all this parallel computing. And actually, if we look what these supercomputers are doing like now, as we speak, so that would be probably these things.
So let me just interject with that real quick, because you did talk about very interesting things right now that we're going to talk about towards this segment about computational supercomputers, parallel programming, and artificial intelligence. And something that caught, and I mean, I'm going to interject this real quick, Dr. Pownuk, regarding about the computational science. And you mentioned that recently we become a little bit more popular. And the reason is because right now there's so much data out there that we want to put it together and then use some crunching data or whatever you want to keep in order to solve a problems. And you did mention about problems in engineering or in science. If you can see this slide, computational science, this is something that we obtain. This is not ours. This is basically, we got it from Wikipedia and some other places. But basically, there is an intersection between the math statistics, as Dr. Pownuk says, the engineering areas, this includes electrical and computer science and information science. And if you see the bottom part, you can see the pure sciences like chemical engineering, chemistry, geography, life science, physics, everything that relates with the pure sciences. They're working together in order to make, they call domain sciences. They make what they call computational science. This is what Dr. Pownuk just mentioned, that when we have a problem in one of these areas that you can see in the left, we need to make sure they, mathematically speaking, coherent, and they're actually reliable, and they're applied to the domain areas. Is that does that make sense, Dr. Pownuk?
Yeah, definitely.
Let's go to the next slide, because the next slide talks about something that you did talk about very, very quickly. Supercomputers.
Okay, so this is very important, of course, because at the end of the day, we need to efficiently compute these models, and what makes possible today's, for example, why machine learning and all this data science is popular now. And there are two main reasons. First reason is that we have more data, like thanks to all this mobile phone, Facebook, and but right now we have lots of sources of data, so it's possible to do some kind of calculations on that. And another reason is why this whole computational science is moving forward is because we have computers bigger and bigger and more efficient, and actually it is possible to compute something, and that wasn't possible some time ago, and not that long time ago actually. So things are moving forward, and right now on the horizon is this quantum computing, and that is even that give us some another possibility. This hardware things is a kind of base and fundament of all that, and without that, actually it's not possible to do lots of things. So yeah, and there are different models. Yes, we have this distributed systems, we have this shared memory system, we have all kinds of other systems. Yeah, so GPU, EPU, and things like that. So yeah, that's so this hardware is very important. And what makes it, how to prove it? Well, so for example, we can look at the market share for like all these companies like Amazon or Microsoft Azure or Google Cloud, and they are getting bigger every year, and there are some reasons for that, and the reasons are, well, we just discussed it. So this hardware things is actually at the bottom of that, because without that we can't move on and do anything.
What we see, what are we looking here right now in this picture?
Well, it looks like Oak Ridge. Some computers at Oak Ridge. I'm not exactly sure what are this particular Oak Ridge National Lab. Yeah, that's one of the biggest.
Yeah, Oak Ridge
And
has right now the Summit, which is considered to be the world's fastest computer. So a supercomputer is not something that you will find in Best Buy or some other store that you can find. This a supercomputer is a collection of computers. It says here that they have 143.5 petaflops. Yeah, and that's a lot. What's a petaflop? Do you know? It's 10 to the power
yeah, so that's lots
12, I
of
think so.
theta. Okay, I
It's a
forgot.
big
But yeah,
number of
yeah.
information.
So that's the number of floating point operation per second.
Yeah,
That would be
and that
10.
will be two. Well, that's a lot of operations per second. They perform more than 200 quadrillion calculations per second. Quadrillion, right? So you have
Yeah.
millions, billions, trillions, quadrillions per second. That's a lot. That's beyond
Ten
understanding.
to the
Yeah,
tetaflop, 10 to the 12
12. Yeah.
operation per second. Yeah.
And usually these supercomputers, Dr. Pownuk, they're used for, can be used for quantum mechanics, I heard, or weather forecasting, climate research, oil and gas exploration, molecular modeling, all those different kind of applications that requires a lot of data, like you mentioned. That's why we need those supercomputers there in order to crunch data. What do they mean with crunching data?
Well, this is the fundamental things nowadays. So, well, we have lots of all kinds of data, and then, well, we need to process, make some sense out of that. So, right now, the most popular things, one of the most popular things is like image processing, and people use it for all kinds of things. And so, for example, okay, let me just look at this because I have some list. So, for example, in medicine, they can detect cancer based on that. So we have some data from patients, some MRI or well, some all kinds of other data, yes, and then well, we just process and we try to check which patient has have cancer and which patients are without cancer, and so that would be one application. Another application is, for example, I'm still talking about like medical field. So that's what I mean by one example of this data processing. You have X-ray, and then you look which this system can detect when bones are broken or not broken, and what else? One second. Diagnosis, all kinds of other diagnosis. So there are some systems which allows to give some early diagnosis. So the patient goes to hospital, and then based on this data, people try to predict whether they are sick or not sick. Right now, there are even some attempts to identify who is sick with this coronavirus or not. So yeah, so this and there are many other applications how it is possible to process data. Oh, that yeah. So oh, that looks like quantum computer, by the way. These slides. And so, should I talk about quantum computer now?
Yeah, so let me just, I have a comment of what you just said. When we have a lot of data, it can be medical, it can be, for example, the weather, in order to predict the weather that was going to happen. what you usually see in the forecast for the next 5 days, maybe 7 days, but sometimes we want to predict the weather for the next year or 2 years, how it's going to be changing. Of course, in order to have that prediction and what they call it, the crunching data, basically you extract all that information from sensors, from different kind of information from antennas, different from the fields. And in order to make those computations in the regular computer, that takes a lot of time, obviously, because there's a lot of data to crunch. So for that, we need those kind of supercomputers in order to make it all those quadrillions of operations per second that I kind of simplify the entire processing instead of just having the entire, I mean, if you want to calculate the weather for the next 3 weeks and your algorithm that you write in your computer takes only 1 year to solve it, well, it's a little bit nonsense to run it. So we need to put it in a supercomputer, that's why. And here's the quantum computer. This is something that is a comparison between the quantum and the summit. Can you please give us a
okay.
description of this?
Yeah, well, this is very new field, so I can just say only something general, but okay. The bottom line here is that, well, the current technology is very fast. All these supercomputers are very fast, but people still try to do it faster. And it is, even though these computers are really well, fast, yes, but it is very easy to create some application which is too computationally expensive for even the biggest computer in the world. So yes, is there any hope on the horizon? And quantum computer is some kind of hope. So there are some recent experiments done by Google, and they claim that they can, they actually did it. They were able to perform certain calculation in such a way that current computer will spend on this problem like 10,000 years, which is very, very, very significant progress. And there are also some problems because some people are afraid that the current, for example, encryption method will be like broken because of that. But I wouldn't worry about this. There are so many things that it's possibly which can be done with this quantum computer, possibly, that this is very, very, very interesting things. And well, another thing is that it's not clear how long we will have to wait for some serious practical application, but well, that's a very promising, let's say, direction, because if we can speed up something, okay, if some calculations can take like it can be done million times faster, that's very, 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 very significant step forward.
Let me just intercept there. Can you see the new screen that I'm sharing?
Yep.
Okay, so recently, the world's fastest computer, which is the Summit, identified a couple of chemicals that could stop the coronavirus. This is critical, guys, because where we happen right now, everything that is happening is very critical. You know that when the biologists, when epidemiologists, they come into place to try to find a vaccine or a medicine to help, it takes a lot of time, a lot of trials in order to make sure to find a vaccine. And based on that, the supercomputer helped the scientists to identify 77 of them. That took a lot of computation. We're talking about months that people can actually go there, scientists go there, try and error, what worked, what didn't work. And based on that, they identify 77 of them. Can you hear me? I just noticed that my connection was stable. Can you hear me?
Yep.
Sure.
Okay, thank you. So the key here was that they use artificial intelligence in order to make decisions. That kind of solves a lot of problems. So right now, and this is Dr. Pownuk's mentioned, when you use machine learning, genetic algorithms, very high complex algorithms to solve these problems, that's artificial intelligence. That reduce the power or that reduce a lot of the possible trial and errors. That saves a lot of time. So identify 77 of them. I'm not so sure how many are there. I was trying to do my research, but I'm not a biologist. I don't know too much about that thing, but 77 was a considerable amount of decisions there that they save. And this is part of the summit. So right now they're getting a lot of interesting a lot of interesting solutions by using computational power. And this is something that you mentioned also about cryptanalysis, how to break it. I know a couple of you here in the room that are interested in cybersecurity. This is one of the reasons why we, and I hate to use the word hackers, want to have access to these supercomputers, because they crunch a lot of data in order to decipher a lot, or to break a lot of information on that. So that's what we have there so far. Someone asked a question. An example of crunching and collecting data could be the recent data that doctors from China upload into the medical information. Definitely something that unfortunately for the past events, a lot of medical, they've been doing a lot of analysis. They put it in data. And because using computational analysis or actually computational algorithms, they identify patterns. And based on these patterns, they reduce a lot of search. They might identify what worked, what didn't work, what caused this infection, what didn't cause this infection, what's the virus. They discard a lot of different things. And yes, we need data in order to crunch. So that's why all the data that is happening gets stored in some database, some information, some cluster. And then you use these computers in order to crunch those algorithms. Of course, it will take a lot of time, but in these supercomputers is not necessarily a lot of time. Do you have something to add on that, Dr. Pownuk?
Well, just one comment. Maybe I will put this on this chat. There is even a web page created by United States government, and they publish some data about this virus. And and actually they announce that this is call for action to tech community. So anybody who can make some contribution in that area, well, is welcome. And this data are published by, let's see, because there is a list. So it's not opening? Oh,
it's not opening, maybe because...
Okay, let's see. No, but maybe...
One.
Okay.
So let's see.
Okay, so, well, no, because...
Nope.
No? Okay, no, let me try. Maybe, okay, I will copy the whole things. Let's see. Maybe, no, it's the same things. So,
Let me just...
okay. Okay, maybe, let's see, because...
So,
okay,
I think...
But it doesn't matter, yes. So let's just say that, you know, it's possible, several, because, you know, okay, doesn't matter. So this is a web page. Oh, that's really interesting. Okay, so it says call for action to the tech community, and these are data published by Georgetown University, Microsoft, National Library of Medicine, National Institute of Health, and several other institutions. And well, it's open, and if anybody can do something about that, yeah, well, yeah. So
yeah. So sorry about the internet is very, I don't know, I guess Zoom takes a lot of that.
No,
but what I can do, Dr. Pownuk, I'm gonna post this in some website, and I'm gonna put those links that are related to that. We have a couple more minutes. Do you have any questions, anyone in the public or in the group, that you would like to ask Dr. Pownuk or would like to share? I read a couple of questions from Mr. Arroyo. He said also about, is computational science considered to be the umbrella that holds all other sciences within? What do you think?
Me? Okay. So, well, I would say this. Everybody is trying to sell products under certain names, and this is another attempt to combine certain fields in one way, yes, to achieve certain goal. And in this case, this is combination some between mathematics, engineering, and computer science. And I would say that is something which I would recommend that for people who are good in one field and then would like to extend their work to some different, to get more broad perspective. So that this computational science is interesting from that kind of people. So, for example, if somebody is computer scientist and would like to do interesting application in certain field, then that computational science can be interesting because you have computer science plus some domain-specific knowledge from the other field, and that would be something interesting. Or, for example, if somebody is engineer and would like to be would like to know more about like application in computer science, then you see we have intersection between engineering and computer science. Or somebody is mathematician, yes, and would like to do more things on computer, then that would be interesting things. However, it's good to, I would say, always remember about some goal, because it's very easy to drown in that.
That's true. Yeah, go ahead. No, I completely agree with you. It's not necessarily, and is what Dr. Pownuk mentioned about is the marketing of how you want to sell this. It's kind of critical these days, because every time that you have, for example, he mentioned you're an expert, for example, at least someone, I know some of you are at least is expert in biology. Yeah, you already have a background in biology, and you want to learn a little bit of computer science or maybe programming in order to probably anticipate something. And what he mentioned is very important. Have something in mind, have an objective, because that's what is basically going to lead you to solve a problem. Because if you say, I like everything, I like math, I like statistics, I like computer science, I like programming, I like a lot of engineering, that kind of, it's too broad, and it's very easy to get lost. I'm a computational scientist, Dr. Pownuk as well. We basically we take courses that basically give you an introduction to computational science, modeling, statistical, things like that. So once you have that problem, you basically concentrate and then move. I don't see it either like an umbrella, but more like a focus in some problem that you actually do interdisciplinary work. That's a good question. Do you have any other questions that you might want to ask, or if you're too shy, you can just write it in the chat.
It is actually worse, because if you write in a chat, it's permanent. If you say, I know it's recorded.
Yeah, I know. It was a trap. That was the trap that I wanted to. I was gonna even talk to them. Any questions that you have? All right, so I'm gonna start calling people then. Just kidding. I'm gonna just mention something about Miguel. Actually, he had some interest in cybersecurity and a couple other people. Is that right, or I'm just making that up?
That's right.
So one of the things that right now in cybersecurity, I did mention very quick about how these supercomputers can help. I'm gonna make another segment on this, doing cryptography and brute force and things like that. So I'm gonna give that maybe next week. It will be a good time to talk about that. But supercomputers that also take place in this whole effort trying to do cryptoanalysis. They call it cryptoanalysis. They cannot say hacking or cracking, but cryptoanalysis takes place very attractively using supercomputers. Let me tell you something. There was an effort when this whole outbreak came out like a couple of weeks ago. There was the hacking community was doing something similar what a supercomputer was doing. Of course, hackers, they don't have access to a supercomputer, but hackers, they doing interesting things. They're collecting using computational power across the globe in order to make the same computational problems, the same computational analysis. So they're solving problems. They're solving the coronavirus, the COVID-19. Of course, they're using the computational power across the world in order to do the same thing that the Oak Ridge lab they're doing. Why didn't went directly to the Oak Ridge? Because of course there's a lot of security concerns. But it's very interesting that at the same time, the scientific community and the hacking community, they trying to solve the problem with the same tool, which is using a supercomputer. The scientific community, they use the Oak Ridge Summit. The hacking community, they use the distributed across the globe power. You probably remember, you probably don't, just the P2P, right? The peer-to-peer. There was some technology that basically you use the computational power across all the computers that are connected to the same node. You probably have heard something called LimeWire, those encyclopedias about what was that, to download information legally. Yeah, so we cannot, it's basically the same principle. You use the same principle. You connect to a couple of computers across the globe, and then you use that computation in order to crunch a lot of data. Very interesting. I'm going to talk about that thing in the next segment. Maybe I'll bring some experts on that. So I want to thank Dr. Pownuk, Andrzej Pownuk, who actually he kindly agreed yesterday about joining us today. Thank you so much, Dr. Pownuk, and thank you everybody who log in here and help us to do this this segment well. If you like it, I'll continue doing these segments probably weekly or maybe every other week. I don't know, something that depends how you like it. Okay. Anything else? Yeah, thank you, Dr. Pownuk. Thank you so much.
Thank you.
Thank you.
I'm gonna pause the recording at this point.